Welcome to Spring LIB.
All right, so we're talking about a glider attached to the end of an ideal spring undergoing simple harmonic motion. So, really, we're just talking about a spring with a mass at the end of it, where the mass is the glider, 0.5 kilograms. The force constant K is 450 newtons per meter. The amplitude is 0.04 meters. That's all the information that we need in order to start calculating this. We want the maximum speed of the glider. Well, in simple harmonic motion, speed is going to be maximized at x equals 0. By conservation of energy, we can write 1/2 m v max squared equals 1/2 k a squared. This is the energy at x equals 0 when we're at our maximum velocity and there's no potential energy. This is our energy when we reach the end of the oscillation. So it's all potential energy with no kinetic energy. Then, very clearly, I can solve for my maximum velocity as a times the square root of k over m, where my 1/2s have canceled out. And plugging in my three values here, I get a speed of 1.2 meters per second. Next, we are asked for the speed of the glider at a particular location. Well, for general velocity in a spring, I can write my horizontal velocity, my velocity along the direction of the spring is plus or minus, because don't necessarily know which direction we're going when we're at this place. Again, root k over m, and the difference between the amplitude squared and my current position squared. I give my current position as, for this, x equals 0.015 meters. And I know everything else. I know the amplitude. Let's go ahead. I've been using capital A. So let's be consistent. I know K, I know M, I know A, and I know X. I can plug all of those in. I get, again, plus or minus. We don't know which direction we're going. 1.11 meters per second. The magnitude of the maximum acceleration of the glider, well, that's going to occur at x equals plus or minus a. Maximum velocity happens at x equals 0. Maximum acceleration happens at the ends. So a is going to be k over m times a. Acceleration is just k over m times x. So we substitute x for plus or minus a. Again, the sign of a doesn't matter here. We're either accelerating in one direction or the other. But again, we know all three of these. So we simply plug in and get 36 meters per second squared. Going to part D, we ask for the acceleration of the glider at a particular point. Well, same process. AX equals KX over M. Default of a minus sign here, but we're given a negative position in this case, minus 0.015 meters. So we find an acceleration of positive 13.5 meters per second squared. Great. Last of all, we are asked for the total mechanical energy of the glider at any point. in their motion. Okay, so, E total is equal to the kinetic energy plus the potential energy. That never changes. We could pick any point, find the kinetic energy, find the potential energy, and add them together. But let's go ahead and make this easy on ourselves, right? If we pick, say, when the glider is at the very end of their motion, then that means that all of the energy is potential. Kinetic energy goes to 0, and it will be 1/2 K A squared. We know all that. So we plug in our spring constant and amplitude, and we find an energy of 0.36 joules. And there we go.